Good morning, all of you. In today's session, we are going to start with the 10th standard chemistry and physics. Unit 9, electrical current. Series number 8 is going to be discussed. Earlier, we completed what is meant by electrical current and how it can be measured, what can be the activity in order to perform relation between the current and illumination of the bulb and a power source called a battery. And in addition to that one, we already completed what is meant by potential difference, electromotive force, and also we performed the laboratory activity in order to get that. So in the continuation of earlier session, we are going to enter into a series number 8. What could be the factors which are going to be going to influence this electrical potential? And even Ohm's law, it's a daily life applications. What are the some what restrictions for that Ohm's law that also completed? So earlier we completed unit number 1 to 8, entire detailed explanation of all these units available on the channel called World of Competitive Chemistry. Let us enter into our series number 8 of unit number 9, electrical current. Now we are going to discuss about the factors which are affecting resistance of the material. Already we know any material was taken based on its resistance, they are categorized into 4 types. One is insulating material, second is semiconducting material, third is conducting material, fourth is superconducting material. These are the main categories based on the resistance. Always any material was taken, instead of its conductance, we are specifically measure its resistance. Based on the resistance, we can assume, we can conclude how extent the conductance will be there, because always resistance is the reciprocal of conductance of the material. Resistance is measured in ohms and the conductance measured in ohm inverse, because it will be a reciprocal value of the resistance. Always resistance mainly depends upon the factor called a temperature. Right, we are going to assume, we are going to analyze what is the relation between the temperature and the resistance of the material. As the temperature rises, how will be the impact on the electrical resistance of given material? Now find the factors. Measure the resistance of the bulb when it is open circuit using multimeter. Multimeter is the device which can be used for either the measurement of resistance, voltage, potential difference, and also conductance of the material. All these can be conveniently measured. Right. Multimeter is the device which used for the multiple applications like resistance measurement, conductance measurement, voltage difference measurement. All these are conveniently calculated by using this a simple device. To measure the resistance of the bulb when it is in the open circuit, we are utilizing this multimeter as a device. To measure the resistance of the bulb, multimeter are used as an ohm meter, because resistance always mentioned in the form of ohms, right? We have to select the knob at ohm meter, right? And place the multimeter knob at 20k ohms. So 20k ohms were selected on this multimeter, and based on this we are going to measure the conductance, measure the resistance of the material. Now place leads of the multimeter on the terminals of the bulb. Here we have 2 leads here, and they are used to connected with the terminals of the bulb. The meter will show one of the following reading. Now either 0.00 or 1 integer may be shown on this one. So this multimeter is used to display either 0 or 1 kind of digital parameters. Actual resistance of the bulb will be shown here. If multimeter is showing as a digit 1, it is regarded as it is overloaded. Now we have to optimize the conditions. It is overloaded now. You need to try higher modes such as 200 k ohms can be taken, or 2 ohms may be taken here. So here initially we are taking multimeter and measuring its resistance, but it is showing only 1. That's the reason why we are going to optimize by changing the selecting knob. So 200k ohms, otherwise 2 ohm knob can be selected on this. If the multimeter reads 0 or nearly 0, when you need to lower the mode to 2k ohm or 200 ohms. So here, if it is showing 0, we have to move the knob slightly lesser than that one. In this manner, the conditions can be optimized. We can adjust the multimeter in such a way so that here readings are correctly given, right? Note the value of resistance in your notebook. So after getting the proper orientation, so where you are getting readings rather than 0 or 1. So if you are getting exact reading, after getting that one, we have to take the reading and that should be tabulated in the notebook. Connect the circuit with the components as shown in the figure. We are taking a battery. Here, key was taken in order to start and stop, and illumination was provided by the electrical bulb with the filament. And here, conducting material is going to connect all the things in order to make the circuit. Switch on the circuit. After few minutes, measure the resistance of the bulb, and again as explained above. So we are supposed to measure its resistance because it should be connected with the multimeter so that it will display its resistance on this multimeter. This entire circuit resistance is going to be monitored. Switch on the circuit. After few minutes, measure the resistance of bulb again. So we are taking initial resistance was measured. After few minutes, again you are going to measure its resistance at different time intervals. As mentioned in the above case, how we performed here in the same manner, we are going to continue the experiment with the time intervals. Note down the value again in the notebook. The value should be tabulated. Then, what difference do you notice in two readings? Initially, without any heating, directly we are going to illuminate the bulb, and at that instance, we are going to measure its resistance. Let us assume after 30 minutes, we are going to repeat the experiment twice a time. The value of the resistance of the bulb in the second instant will be more when compared to the open circuit initially. After 30 minutes, the resistant value will be higher. So that is increased in a certain manner when compared to the initial one. Here, what could be the reason for that one? Now, so what could be the reason for the increase in the resistance of the bulb when current flows through it? So why initial resistance is lesser? After time interval, it got gradually increased. Then, can you explain the reason for this kind of as time passes, what happens? Resistance also increased. This is the activity we are going to perform. So this activity can be done by taking all these operators, and we already made the circuit earlier, so that here all these are connected and we are going to connect with the multimeter and the values can be noted, and we are going to find the reason why after certain time there is a rise in the resistance when compared to the initial one. This answer I collected from the Brainly platform. Thank you very much for your valuable information. The resistance of the lamp increases as the temperature of the filament rises. So here, there is a relation between resistance and the temperature. What happens? Initially, bulb filament is able to start glowing by getting the electrical potential as well as the strength of the current. As time passes, what happens? There is a slight rise in the temperature is possible. Heat is supplied so that here temperature will be raised. As the temperature rises, resistance of the material is also rises. Resistance is a parameter which used to oppose the flow of current. The current flowing through the filament lamp not directly proportional to the voltage across it. Here always current flow is not exactly related with the voltage. So if voltage increases, strength of current also increases. There is no such a kind of direct relationship. Both are individual properties. Current is amperes, voltage is volts. Both are individual properties and both are required to supply in order to illuminate the bulb and in order to perform the activity. Now, the conclusion will be, what could be the reason for increasing resistance as we are increasing the time of illumination? Because as the temperature of that conducting material rises, then electrical resistance is also rising in the similar manner. There is a direct proportionality between temperature and resistance. You will notice that bulb get heated. So after half an hour, if you are going to touch the bulb, so that will be you are experiencing that is rise in temperature, that is heated some extent. The increasing the temperature of the filament in the bulb is responsible for the resistance of the bulb. So as the temperature rises, its resistance also increased. That's the reason why there is a direct proportionality. Hence, we can conclude that there is a relation between resistance of the bulb and the temperature. What kind of relation you can find? Temperature is directly proportional to the resistance. As the temperature rises, resistance of the material also increases. Correspondingly, conducting nature of that material get decreased. If you are taking copper wire, when you are conducting the current, what happens? Conduction will be possible. We are taking copper wire and kept on the flame, luminous flame. After some time, it got completely red hot. At that condition, again, you are going to supply the electricity. What happens? Conductance get decreased. As the temperature rises, conductance of material get decreased because its resistance got increased. Resistance and conductance both are reciprocal to each other. That's the reason why temperature rises, its resistance also rises. Thus, the value of resistance of the conductor depends upon the temperature for the constant potential difference. If potential difference, EMF taken as a constant value, for example, 24 volts of current is 24 voltage of current is able to pass through the conductor, that kept a constant. What we are doing, we are rising the temperature. As temperature rises, its resistance also rises in the similar manner between the two ends of the conductor. The simplest example is take the copper wire and conduct the current. Take the heated copper wire and conduct the current. You can notice what kind of difference you can experience. Obviously, normal copper wire having higher extent of conductance when compared to the heated copper wire. This is the relation between temperature and resistance. Temperature is directly proportional to resistance. By this, we completed the session. Hope the session will be helpful for your preparation. Thank you very much for your consistent listening. Thank you, one and all.